What is infinity? Infinity is kind of vague concept, but actually it's not. It's mathematically defined very well. Infinity is not a real number. See, we learn since elementary school whole number, 1, 2, 3, 4, 5 and stuff, and integer, including negative number, and we expand it to rational number, which is the ratio of the integer. Then we learn the real number, okay? But they are all specific. So what do you mean by specific number? Well, you know the exact value. That's what it means, okay? The infinity doesn't have an exact value. So infinity is not a specific number. Any number you tell me plus 1, that's can be infinity. Any number you think multiply by 2, that can be infinity, right? Okay, so real number is a specific number, 3 minus 5 and pi, but infinity is a not. So we have another non-specific number, infinitesimally small or close number. For example, larger than 1 but infinitely close to 1. Okay, we write 1 plus, infinitely close to 4 but less than 4. We write this way. It's not specific, it just shows the characteristic of the quantity. Okay, the infinitesimally close number is bounded by a real number. Okay, so this bound, the number that bound infinitesimal number, is expressed by limit. That's the meaning of limit. Say limit 1 plus equals 1, limit 4 minus equals 4. Okay, so example of 1 plus, it can be 1 plus 1 over n, and n goes to infinity. 4 minus can be 4 minus 1 over 2 to the nth power, n goes to infinity. Okay, this is infinitesimally small. This is also infinitesimally small. Okay, so I tell you why it's not specific. This looks like a specific, but actually it's not. 1 plus, for example, this is also 1 plus. If you add up all of this number, it becomes infinitely close to 1. Actually, in this case, 1 minus. Correction here. Okay, so why even you write this way? It's not specific. Well, for example, infinity itself is not specific. Say you have 1 plus 1 plus 1 plus 1 all the way. That goes to infinity. If you add a 1, what's happened? 1 plus 1 plus 1 plus the same infinity. There's no difference. Okay? So you add extra 1, it's still infinity. So it's not specific. It doesn't have a specific value. And then why in the math textbook they suddenly mix those non-real number into what you learn so far is a real number in high school and confuse the student? Okay, see, this is the problem with the math textbook. They just suddenly mix them without any definition, just real number and infinitesimal number, infinite, and confuse student. Okay, this is the source of your confusion about calculus. But once you know what it is, it's nothing mystical, nothing mysterious about it. Okay, the limit means so then what do we use? Why we need those new numbers? It's not real numbers. Well, if we take a limit of the ratio of infinitesimal small number, that could be a real number. Of course, we need a limit, and something going to infinite or zero, whatever. This action make it number unspecific. It's infinitesimal number. Okay, but the ratio, the limit of the ratio can be the real number. Okay, this is the calculus. This is differentiation. How about definition of this is a differentiation. This should be belongs to up there. And when you take infinite number of sum of infinitesimally small number, that could be the limit produce a specific numbers, a real number. So this is the definition of integration. Okay, so the calculus is all about, the core concept of calculus is all about this ratio of infinitesimally small number, or the summation of infinitesimal number for infinite number of times. Okay, that's what it is. So in order to achieve this, we manipulate the equations and get the derivatives and integrals. And once you understand that, it's nothing mysterious about the calculus. For example, limit delta x goes to 0, delta fx, this is a function value at the x, and delta x. Okay, so this is the ratio of infinitesimally small number is written as f prime x. X is a parameter now at the point x. So this f prime value depends on x, and we write it dyx over dx, and here x is a parameter and dy dx are variables. Okay, so this is simply same as this equation. This is a variable, and this is the coefficient a, but there is a parameter x. Depend on the x, the value change, coefficient change. Okay, so this is the derivative function. So what is integral? Integral is limit delta x go to the 0, and this is infinitesimally small number because delta x is very close to 0, and you add up from arbitrary constant a to x prime, then you get the function with the parameter x prime. Okay, and that's why summation always has some constant c, which is related to arbitrary number here. Okay, so this is integration. So that's all about calculus. Okay, the remaining is just details. This is the core concept of calculus. So once you understand this, you have no problem with calculus. I hope you enjoy this video. Please check other videos. We have other videos. Thank you for listening.